plus 4 plus 4a plus a squared. That's minus 2 minus a squared. Because I've got a squareds, actually I don't need to take it all across to one side. Plus a squared on this side cancels with the plus a squared on that side. Take the a's across, so I'm left with minus 6a minus 4a is equal to 25 plus 4 minus 1 minus 9. That means that minus 6a minus 4a is equal to minus 10a is equal to 25 plus 4, which is 29. 29 minus 9 is 20, minus 1 is 19. That means that a is equal to negative 19 over 10. That's that point over there, negative 19 over 10. That's the x value. And that does make sense because negative 19 over 10 is the same, or more or less it is the same as negative 1.9, which we can see is just slightly below negative 2. So that holds true. Number 3 gives us this graph over here, PQ. Q is the coordinates A and B, R and S. P, R and S have all got their coordinates. They ask us to find A and B, which are the coordinates of Q, if PQ is perpendicular to RS and Q is equidistant from R and from S. Now let's start with this equidistant bit, because that looks like the more difficult one to do. If it is equidistant, it means that QS is equal to QR. That means that QS squared is equal to QR squared. QS squared, remember using the distance formula, is going to be y2 minus y1, which is b minus minus 4, or b plus 4 squared, plus x2 minus x1, which is going to be a minus 2 squared, and that should be in the square root, but remember we're squaring it to get rid of the square root. Similarly with QR, we're going to have b minus 3 squared plus a plus 4 squared. I'm not going to simplify this out. Actually, I am going to simplify this out. B plus 4 squared is going to give me b squared plus 4b plus 4b is plus 8b plus 16 plus a squared minus 4a plus 4 is equal to b squared minus 6b plus 9 plus a squared plus 8a plus 16. I've got a b squared on both sides of the equation. They cancel each other out. I've got an a squared on both sides. They cancel each other out. I've then got 8b plus 16. Take all the b's and a's to one side. So 8b minus 6b taken across becomes plus 6b. 8b plus 6b is equal to 14b minus 4a minus 8a, when I take it across, will be minus 12a plus 16 plus 4 is going to give me plus 20 taken across to the other side is equal to plus 9 plus 16 is plus 25. Plus 25 minus that 20 is going to give me plus 5. That means that 14b minus 12a is equal to 5, and that's my first equation. I've got two variables, hence I'm going to have to solve simultaneously. Do I have another equation? Thankfully I do. They tell us that PQ is perpendicular to RS. That means that my gradient of the one will have to be the opposite negative gradient of the other. Let's just erase this and keep this equation. So we've got our first equation being 14b minus 12a is equal to 5. That's equation 1. Now, our gradient m of rs is equal to y2 minus y1, which is minus 4 minus 3, over x2 minus x1, which will become 2 minus minus 4, 2 plus 4. Minus 4 minus 3 is minus 7, over 2 plus 4 is 6. So our gradient of rs is negative 7 over 6. That means that our gradient of pq has to equal 6, positive 6 over 7. But we know that the gradient of PQ is going to be given by y2 minus y1 over x2 minus x1. Minus minus 3 is plus 3, minus minus 4 is plus 4. That means that 6 times a plus 3 is equal to 7 times b plus 4. All I've done is I've cross multiplied. That means that 6a plus 18 is equal to 7b plus 28. 6a plus 18, what I'm going to do here is I'm going to get it in terms of 6a. That means that 6a is equal to 7b plus 28 minus 18, which is plus 10. And that's my second equation. 6a is equal to 7b plus 10. Remember, I got to this using the gradient of the one being the opposite gradient of the other. Now, what I'm going to do now is use these two equations simultaneously to get my values of a and of b. Here I've got 6a is equal to 7b plus 10. Let's convert that one. Let minus 12a, take the 12a across and the 5 across to the other side. That means that 14b minus 5 is equal to positive 12a. Swap it around and divide by 2. That means that 6a is equal to 14 divided by 2, which is 7b minus 5 over 2. There is going to be a slight problem with this. I've now got two equations in the form 6a is equal to. The problem with this is that if I substitute that in place of that, I'm just going to cancel my 7b's out altogether. So unfortunately this one is not going to work out like that. What I think I'm going to do with this one rather is, let's rather get it in the form 7b is equal to 6a minus 10. That means that 14b is equal to 12a minus 20. Again, if I substitute it in, I'm going to cancel. Now I've just realized that because q is equidistant from r and s, and that is perpendicular to that, there could be a number of different a values. We could have a values there, we could have a values there, and that would all be equidistant. We could even have values there or there. So, in effect, there is a relationship between a and b, which would be the gradient of PQ, but there are no fixed values of a.